Why does fire exist? It seems like a simple question. Almost childish. You've seen fire your entire life. Candles, campfires, gas stoves, a spark, a flame, heat, light. Something burns. That's fire. End of story. Most people never ask anything more. Fire just is. It's hot, it's bright, it destroys things. That feels like enough. But it isn't, because when you actually stop and ask what fire is not how to use it, not how to control it, but what is really happening when something burns, you uncover a story so deep, so elegant, and so completely connected to everything else in nature that it permanently changes how you see the world. Fire is not just a thing that happens. Fire is a window into how atoms behave, into how energy moves, into how the sun powers life on Earth, into why trees exist, into why you exist. Let me show you. Start with something ordinary, a piece of wood, dead wood just sitting there. It could sit there for years, decades, even centuries. Now add air, oxygen fills the space around it. The wood is there, the oxygen is there, nothing happens. That's already strange. Inside the wood is carbon, and oxygen has a very strong attraction to carbon. When carbon and oxygen come together, they release a lot of energy. Carbon dioxide is a lower energy, more stable state than carbon and oxygen separated. So if carbon and oxygen want to be together so badly, why doesn't the wood burst into flames on its own? Why does it just sit there? The answer is that wanting something and being able to get it are not the same thing. There is a barrier. At the atomic level, carbon and oxygen are constantly colliding. Millions of collisions every second. But at room temperature, those collisions don't have enough energy to trigger a reaction. The atoms bump into each other, bounce apart, and try again. Over and over, nothing changes. To understand this, imagine a ball near a deep hole. The hole represents a lower energy state. The ball wants to fall in. But between the ball and the hole is a small hill. Unless the ball gets enough speed to climb the hill, it rolls back. Carbon and oxygen are like that ball. The bonded state, carbon dioxide, is the hole. But to get there, the atoms have to climb over an energy hill called the activation energy barrier. At room temperature, they can't do it. So the wood waits, the oxygen waits. Everything stays the same. This state can last for 1,000 years. Then you strike a match. That tiny flame heats a small region of the wood. Heating means atomic motion. The atoms jiggle faster. A few collisions now have enough energy to get over the barrier. Those atoms snap together, and when they do, they release energy. That released energy makes nearby atoms jiggle faster. Those atoms can now get over the barrier too. They react, they release more energy. That energy spreads. More atoms react. One reaction becomes two, two become four, four become eight. Within a fraction of a second, the number of reacting atoms doubles again and again and again. That runaway process is fire. Fire doesn't grow gradually. It explodes into existence because it's a chain reaction, a positive feedback loop. Heat creates reactions. Reactions create heat. The process feeds itself. Fire is not a substance. Fire is a gas processing. It's a catastrophic cascade of atoms snapping together, releasing energy faster and faster, until billions of reactions are happening simultaneously. The heat you feel from a flame is not a mysterious fluid. Heat is not a thing that flows. Heat is motion. It is atoms and molecules jiggling faster. Put a cup of coffee near a fire and the coffee heats up because the fast-moving atoms in the fire collide with the slower-moving atoms in the cup, transferring motion. That's what temperature is. That's what warmth is. Fire is motion unleashed. And once it starts, it sustains itself. As long as there is fuel, oxygen, and enough heat to keep atoms moving fast, the process continues. Remove any one of those, cool it, starve it of oxygen, remove the fuel, and the loop collapses. That's how fire dies. But this only answers how fire works. It doesn't explain something deeper. Where did the fuel come from? Let's talk about the wood itself. Where does a tree come from? Most people think trees come from the ground. You plant a seed in soil, the tree grows, so it must be made of soil, right? That seems obvious. It's also wrong. Almost all of a tree's mass comes from the air. The carbon in the wood comes from carbon dioxide. The hydrogen comes from water. The oxygen comes from both. The soil contributes only trace minerals. Those minerals are what you see left behind as ash after burning wood. The wood itself, the part that burns, came from the air. This sounds unbelievable until you test it. In the 1600s, a scientist named Jan Baptist van Helmont performed a simple experiment. He weighed a pot of soil, he planted a tree. For years, he watered it carefully. When the tree was large, he removed it and weighed the soil again. The soil weighed almost exactly the same. The tree had gained hundreds of pounds. Where did that mass come from? Not from the soil. It came from the air. Trees are made of air that has been rearranged. So how does a tree pull carbon out of carbon dioxide when carbon and oxygen cling so tightly together? Because the tree doesn't do the work. The sun does. Sunlight strikes the leaves. That energy is used to rip carbon dioxide molecules apart. The carbon stays, the oxygen is thrown away as waste. Photosynthesis is not magic, it is work. Real physical work. Energy is being spent to push atoms away from equilibrium, to create structure from disorder. The sun is constantly pumping energy into the system. That energy is stored in the tree's structure, in chemical bonds. The carbon and oxygen are held apart, separated against their natural tendency to reunite. That separation is stored energy. The tree spends years collecting sunlight photon by photon, using that energy to build itself. Now remember fire. Fire is carbon and oxygen snapping back together, which means fire is undoing the work of the tree. When you burn wood, you are releasing energy that was stored by sunlight. Fire is stored sunlight escaping. The flame in your fireplace is the sun delayed. The light flickering in the fire is sunlight that fell on leaves years ago, sometimes decades ago. The heat warming your hands is energy that once traveled 150 million kilometers from the sun to Earth, was captured by a leaf, stored in chemical bonds, and released again in seconds. A burning log is the sun shining again. Now ask yourself something else. Why doesn't wood just spontaneously catch fire? If carbon and oxygen want to be together so badly, why do we need a spark? Because the system is metastable. It's like a boulder balanced near the top of a hill. It wants to roll down, but it sits in a small dip. As long as nothing pushes it, it stays there. Wood and oxygen are stuck like that. They want to react, but they can't get started without help. The match provides the push. Once the boulder starts rolling, gravity does the rest. The universe is full of systems like this: food and oxygen, gasoline and air, even your own body. They all contain enormous amounts of stored energy waiting behind an activation barrier. That's why your food doesn't burn inside you. Instead, enzymes lower the barrier. They control the process. They let reactions happen slowly, safely, step by step. Which brings us to something profound. You are burning. Inside your cells right now, carbon-based molecules are combining with oxygen. Energy is being released. That energy powers everything you do. The chemistry is the same as fire. The difference is control. Fire releases energy all at once. Your body releases it slowly, capturing it in molecules like ATP. You are quite literally a slow fire. The carbon dioxide you exhale was once part of a plant. That plant pulled it from the air using sunlight. You released it again. It's a cycle. Sun-gi plant, animal gear plant again. Carbon circulates. Oxygen circulates. Energy flows. Fire is just that cycle made visible. Now consider oxygen itself. Where did the oxygen in the air come from? Early Earth had almost none. The atmosphere was mostly carbon dioxide, nitrogen, and water vapor. Then photosynthetic organisms evolved. They began ripping carbon dioxide apart and dumping oxygen into the atmosphere as waste. For them, oxygen was poison. The rise of oxygen caused one of the greatest mass extinctions in Earth's history. Entire ecosystems died, but some organisms adapted. They learned to use oxygen to extract energy from food. That adaptation made complex life possible, and it made fire possible. Fire exists because life reshaped the planet. Every flame you see depends on billions of years of photosynthesis. Fire is not ancient. It is a consequence. Look closely at a flame. The light isn't random. It comes from electrons jumping to higher energy levels and falling back down, releasing photons. Different atoms emit different colors. Sodium glows yellow. Copper glows green. That's why fireworks have colors. The smoke is unreacted carbon and other particles rising because hot air is less dense. The ash is the tiny fraction of the tree that came from the soil. Everything else, the carbon, hydrogen, and oxygen, has turned into invisible gas and drifted away. The mass didn't disappear. It changed form. Fire doesn't destroy matter. It rearranges it. So why does fire exist? Because the sun shines, because plants capture that energy, because atoms seek lower energy states, because energy must flow. Fire is not destruction. Fire is a return to equilibrium. It is stored sunlight released, stored order collapsing back into motion. A flame is not just burning wood. It is the visible echo of sunlight that fell on Earth long ago. And once you see that, once you really understand it, you can never look at fire the same way again. The next time you see a flame, you are watching the universe relax. And that is why fire exists.